Redshift. Is the universe expanding or just slowing down? When we look out into the universe, one of the clearest things we see is redshift. Light from distant galaxies arrives stretched, redder than when it was emitted. Distant events also appear stretched in time. That observation is solid. The usual explanation is that space itself is expanding. As space stretches, light stretches with it, and over time, that expansion even appears to accelerate, which is where dark energy enters the story. But there's a quiet assumption sitting underneath all of this. We treat the rate at which time flows as fixed, the same everywhere, at all moments in cosmic history. That assumption is built into our space-time diagrams and equations, but it's not something we ever directly measure across the age of the universe. Relativity actually allows a different, equally valid way of describing the same space-time. Instead of thinking of space changing through time, we can think of space as a stack of extremely thin present moments, slices of space, moving through time. The rate at which those slices advance is what we experience as proper time. In standard relativity, a change in spatial scale and a change in temporal scale can be mathematically equivalent. You can move the scaling from space into time or from time into space and still describe the same observations. So the question becomes, what if the universe moved through proper time more quickly early on, and that rate has gradually slowed? If that were the case, clocks in the early universe really did tick faster. Physical processes unfolded more quickly. Light emitted then naturally had higher frequencies. That light travels across the universe unchanged. But when it's measured later by clocks that tick more slowly, its frequency appears reduced. Redshift emerges as a comparison between different cosmic tempos. The same reasoning explains why distant events appear stretched in time. They didn't unfold slowly when they happened. We're observing fast past processes using a slower present. What's striking about this perspective is how much it simplifies. Effects that look like accelerating expansion can arise from comparing different clock rates without introducing an additional mysterious energy. And observations from the James Webb Space Telescope, galaxies that appear surprisingly mature very early in cosmic history, feel less rushed if the early universe accumulated proper time more quickly. Nothing about the data changes. The light is the same light. The measurements are the same measurements. What changes is where we allow the scaling to live, in space or in time. Relativity gives us more interpretive freedom than we often remember, and that sometimes shifting perspective can make the universe feel simpler rather than more complicated.